Hello, this video goes over project number 3 in the Arduino Starter Kit, whether you're following along with your starter kit or on TinkerCAD.com, so stick around. Hello, all right, I'm going over lesson 3 today. If you haven't seen my other ones, please make sure, check them out. I'll put them in a playlist or at least a video up above. Go into TinkerCAD, log in, click on Learn, change this over to Circuits. I do have a series on starters if you need help going through those. Otherwise, click on Projects. We're going to say Show All Arduino and scroll down. If you're working on this just with your normal Arduino Starter Kit, this will be the same thing, just with a little bit more guidance. Okay, so it says Love Ohm Meter. Click on it. And then you are going to click on Introduction. As always, it's on the left-hand side, what we need to be doing. And then we'll have the thing in the center, be able to pull everything we need from the right-hand side. In this project, you will turn the Arduino into a love machine. Use a temperature sensor to measure your skin temperature and register how hot you really are. Even though the Arduino is a digital tool, it can interpret signals from an analog input like the temperature sensor using the built-in analog to digital converter accessed through the analog pins. And these are the analog pins. It says analog in, and these are the digital pins. So we'll click next. In this project, okay, it says the same thing. All right, in this circuit schematic below, you can see that the temperature sensor is connected to the power and ground and the analog pin. If we look, we have the temperature sensor. It's connected to analog 0. It's connected to a 5-volt source as well as connected to a ground. All right, and then we'll see there are actual LEDs that we're connecting as well. You can also see that 3 LEDs are connected to their own digital pins. For those of you that aren't sure what these are our resistors, and these are LEDs. So in a schematic, this would be what an LED looks like. Electricity only flows one direction through them. And then these are our resistors, so they slow down the flow of electricity. If you watch my previous video, you know that's because if we just had full 5 volts of electricity running through there without a resistor, it would burn out our LED. It wouldn't work. So if you are working on this, make sure you're physically working on this, you have it at home. Don't just connect those LEDs without the resistor on the right spot. Always double check. All right, we'll click next. You will need the following electrical components. So we need a temperature sensor and 3 red LEDs, as well as 3 220 ohm resistors, and of course your Arduino Uno board and a breadboard. Breadboard here, Arduino Uno. If you have a physical kit and are building the project at your desk, you also need paper, scissors, and markers. You don't have to do that. All right, so can you match each component on the list to its location on the breadboard? All they want you to do is look and see 3 LEDs, 3 resistors, temperature sensor, and then where the positive and negative are. We'll go next. Maybe this is where we connect it. You can read that. I won't read that through the whole time. It says analog in pins A0 through A5. Those are analog 0 through analog 5. They receive information, translate that voltage. It takes a voltage in, translates it to a value between 0 and a 1023 for the Arduino sketch to use. The analog pins can only be used to read information from sensors and not to write information. So this is not going to be sending information out. It is going to be receiving information from sensors. All right. You'll be using a temperature sensor to measure how warm your skin is because you'll be touching it with your finger. In this case, if you're using TinkerCAD, obviously you won't be touching it. The temperature sensor has 3 pins. So if we're working on this, we can look, there are 3 pins on our temperature sensor. One that connects to ground, another that connects to 5 volts, and a third that outputs a variable voltage to your Arduino. You can think of it as a power component that outputs a variable voltage. So find the temperature sensor in the components menu. All right, we found it. In the sketch for this, you'll read the sensor's voltage at analog pin 0, A0, analog 0, and use it to turn LEDs on and off, indicating how warm you are. There are several different models of temperature sensor. This model, the TMP36, is convenient because its output voltage is directly proportional to the temperature in degrees Celsius. We'll get to that in a minute. The left side is where 5 volts connects, so electricity runs in here. It goes out through the ground, but while it's running, it also lets out a certain amount of voltage out here that corresponds to a reading that then your Arduino can be like, hey, it's that temperature. So we'll get there. Arduino IDE comes with a tool called the serial monitor, and this is a cool thing. You can play with other sensors and figure out exactly what information it's sending by looking at the serial monitor. You can get information about the status of sensors, and you can get an idea of what is happening in the circuit and code it as it runs. All right, so in the simulator, open the code editor window. This one, I don't know why I had trouble finding it, but it says okay, the serial monitor is accessed using an icon in the top right corner. That is incorrect. It's actually down here. Here's our serial monitor. All right, and that will show us information. Obviously, right now it's not showing anything because we don't have anything hooked up, but it's down at the bottom. It is not at the top right. Then we click done, continue. We'll move on to setting up the circuit. All right, setting up the circuit. Now we'll build our simple circuit. So we click next, and what I always do is I just look here and I will walk you through that setup. So we have a positive running from 5 volts to this rail, which fills those up. A negative that runs here. If I'm going a little fast, watch the other project that I went through, and it'll make a little more sense to you. Okay, I walk through every single thing, the way the breadboard works and all that stuff. We have those resistors color coded. And I'll walk through that, and the LEDs facing the correct way. So I'll do the LEDs first because that seems to be the easiest thing right there. They had one connected there. I believe they had one space in between them. I'll double check it. They had 2 spaces in between them. Sorry about that. So we have 2 spaces. Perfect. We have a positive. So running from 5 volts up to the positive. Turn that to red because positive should be red. Keep things organized, ground to ground, make that black. Hopefully you knew that already. Then what we have running from pin 4, 3, and 2. It's running to that right side of the LED. So 4, 3, 2. So I go from 4, right, 3. Let's check that. That one's good. 4, 3, and 2, and we want to change those to red because electricity is flowing through them. So you just click on it. It's because it's positive. Apologize for that. If you make a mistake, just hit back, click on it, change it to red. This is just to keep it organized. If you're doing this with your kit, if you don't find the right colors, it doesn't matter. They're the same. Then we had resistors, and those resistors were running from the negative rail to the left side of the LED. So we take that and we run it. 1, 2, 3. And for those of you at home, definitely make sure you're choosing the correct one. If we look, those are supposed to be 220 ohm resistors. So look, you'll see this is brown, black, red. I don't know what that is, green. We want to change them to 220 ohms. And so you'll see as I do that, the rings change. So we're going to change that to 220, not 1000. So 220, and the rings change. So these should be the correct color now, that one, which it is, okay? So please make sure if you're doing this at home, make sure that you're choosing the correct color. If you're not choosing the correct color, you might burn out those LEDs. You might cause damage to your board. You don't want to do that. And obviously, if you're doing this on TinkerCAD, you want to make sure you're doing it correctly. And we look, and that's correct. Now we're missing our temperature sensor, which I'm guessing it'll go there. But basically right now what we've got is positive running through this rail. The positive has nowhere to go. But the negative, the ground, if electricity flows out of this digital output, which we'll set it as an output, the electricity could flow then through the LED, through the resistor to ground. Now, if you go to use this, if you're using this in real life with the kit and your LEDs don't light up, you probably have them facing the wrong direction. Just pull them out, flip them around. The electricity only flows one direction through diodes, and this is a light emitting diode. So just turn them around and you'll be all good. If you were looking at the drawing in the starter kit, they'll actually show what the inside of the LED looks like. For some reason, they didn't do that here. All right, so we're all set there. We'll click next. Connect the temperature sensor. So we will just look where it's connected, and I'll talk you through it. Grab the temperature sensor, and it's connected 4 over. So remember, you can just type temperature sensor. If you are That's interesting. If you're doing this in person, please make sure that when you are getting that temperature sensor that it actually says TMP. Otherwise, it might be something else, okay? I believe that was 5 over that I was supposed to connect it. Let's see. 4 over. I was talking too much. Remember the positive, and actually if I mouse this over, the 5 volts goes there. Then this goes to the analog. That is voltage out, and then this is ground. So we wouldn't even have to look at that, but we can. So we've got this side, and it doesn't matter which one you connect. I like to make it as organized as possible. If you're doing this in person, this might be a little hard to do such a small wire. You can connect into any of those holes there. This one should be going to the analog input. And you'll notice that goes to analog input 0, and they're leaving that green. Remember, the color doesn't matter, but keeping it organized is nice. And then this is a ground, so it should be running to the ground. And we make that black if you care about color. Remember that this can be connected to any of those, so that it can't be connected to these, but any of these it can be connected to. It doesn't matter. This is just to keep it nice and visually able to look at things and add components. So wiring up the temperature sensor, so the left pin, we did it to the analog 0 and the right to the ground. And then we click done. Awesome. Then we need to write some code. All right, so it says now we'll write our meter code, and we'll click next. Now, in the last lesson, I really didn't like how they introduced this code, so we'll see how they did that in this one. In this lesson, you'll program the Arduino to figure out how warm the temperature sensor is, then light up the 3 LEDs like a bar graph. All 3 LED lights light up if your hand is really warm. In the next lesson, you'll learn how to change the sensitivity of the sensor so it works well for you. Open up the code editor, and let's get started. So we click on code editor. That's open. And we click next. As usual, you'll start off the code by creating some definitions, constants. Now, just like last time, I'm going to bring the code in and then walk you through it, okay? You're more than welcome to go through this, but I'm going to walk you through the code. So be back in just a second. All right, to get this code, what you want to do is you want to, if you were working with the physical kit, you are going to download the Arduino software. And what you do is then go up to File, Examples, Starter Kit Basics, Level Meter. If you don't have it and you're just working in person, I'm going to copy and paste this, and we'll go through what you need. It does look like a decent amount, but as always, it makes sense, and we'll walk through it. So I'm going to copy it. I'm going to paste it in here. So it may be a little bit different than if you had walked through it yourself. They do want us to define our constants. These are things that are always there. As always, I want to give a little credit to who wrote this. It says Arduino Starter Kit Example, Project 3. The sketch is written to accompany Project 3. It's got these parts, which we talked about, and Scott Fitzgerald. Good job. Thank you for writing this code and sharing it with the world. So it says name the constant for the pin the sensor is connected to. So we are saying there is some constant integer that we're going to call sensor pin. Now the capital P makes a difference, so make sure it's capital P so it matches my code, and it equals analog 0 input. So what we're saying is we are calling analog 0 input in our code sensor pin. You could just get rid of this and leave it as A0 the whole time, but it's easier to write code when you're naming it something that makes sense for you. So the sensor is connected to A0. That's what we're saying. And then it's saying we have a constant float, so something's going to change. Baseline temperature equals 20. We'll get to that in a minute. We're saying that the room temperature is 20 degrees Celsius. Obviously, you could do that in Fahrenheit if you want. Those are the constant integers. Now we're going to move forward in this code. Then they talk about initializing the serial port. We're going to do that as well. It says in the setup function, which is right here, void setup. This runs one time when you turn on your Arduino. You're going to use a new command, serial begin. It looks complicated, but it's not. You just copy and paste this. This opens up a connection between the Arduino and the computer. So if you're doing a physical connection, you're going to do this in real life. You're connecting your USB and leaving it connected to your computer so the computer can receive that serial information. So you can see the values from the analog input on your computer screen. The argument 9600 is the speed at which the Arduino will communicate. So you'll see I'm saying serial begin at 9600 baud. That's just the speed. All right. I think you always just use that number with it. You will use the Arduino IDE's serial monitor to view the information you choose to send from your microcontroller, and we'll see what that does in a minute. So get that code. We have it set up. All right, all they're asking you to do that, and in the code it says open a serial connection to display values. Then we click next. Initialize the digital pins. So next up is a for loop. So if we're looking at this, we have this. It says set up the LED pins as outputs, and then the for loop saves some extra coding. So what we're saying is for the integer, pin number equals 2. So we're saying if we wrote pin number, it would equal number 2. If pin number is less than 5, then add to the pin number. Pin mode, that's interesting. Okay, so we can walk through what this means. So you'll remember that we have pins 2, 3, and 4 connected, right? So 2, 3, and 4 are connected to LEDs. Instead of writing out each one of those, which I actually would have done because I guess, I don't know, they want to save us time, but I don't know if this saves time for the 3, but maybe setting up if we had all the pins connected. So we're saying there's pin number 2, 3, and 4, and it's connected to an LED. What we're saying is we want to make these pins equal to outputs. So it's going to put electricity out. And then digital write, we're going to say all those are on low, meaning they are not lit up. Now what this means is we are going to start on pin number 2. Okay. Then we're going to create we're going to, all these pin numbers, see how I can walk you through this. Pin number 2, then it's going to say do this for that pin number 2. Then add 1, that's what this means. Add 1 to that pin. So make it number 3 and do this. So then it's going to set number 3 to an output at low. And then add another. So now it's 4 and make number 4 an output in low, as long as the pin number is less than 5. So then it adds 1 more. The pin number is now, it went from 4 to 5, so it stops doing this for loop. All right. So basically it saves you a little bit of time. And so if I wanted to set up all these pins, I could change this to, less than, they could go up to 14, and that would set up 2 through 13 all as outputs at low. So I hope that makes a little sense. This pin number, it's just saying the next time you go through this loop, add 1 to it. If it didn't make sense, copy and paste it. Go through the code.org lessons I have, and it will walk you through that. Codecademy does a really good job on that as well, and I'll make some videos about Codecademy in the future. All right, moving forward. Well, maybe I'll read what they say. The above code starts by setting pin 2 as an output pin and giving a value low. Then it increases the pin number to 3 and starts again. And so it does the same thing. The last bracket that you add is not part of the for loop. It is used to end the setup function. All right, so it says the last bracket that you add is not part of the for loop. It is used for this to end the setup function. So in order to end what we're doing, we need to make sure that we have that end bracket, okay? If your code's really messing up, sometimes you'll be missing that end bracket. If you'll notice, there's an end bracket here. This begins that bracket. This ends that one. So then this one it started here at the beginning of void setup, and it ends here. If you don't understand brackets, go through Codecademy, codecademy.com, I believe it is, or maybe .org. I think it's .com, and go through some of those programming if you really, really want to understand those pins. Otherwise, just think of these as parentheses, and we're saying do all this in between. And so if you don't have an ending bracket or you have like an extra bracket, the computer will get confused. All right, we move forward. Read the temperature sensor. So now we are going to start a loop. Remember, the setup just runs once when it turns on. And now a loop is going to run over and over and over and over and over again. All right. So it says in the loop function, you'll use a local variable named sensor val. So if we look here, we have sensor val, to store the reading from your sensor. To get the value from the sensor, you call a function called analog read. So that is just a function. It's a defined function. It's saying, hey, read on the sensor pin, which we had defined sensor pin as A0. So what it's saying is take a reading from A0. What reading is it getting from the temperature sensor? And make that equal to the sensor value. All right, to this variable that we're calling sensor val. Analog read takes one argument, what pin it should take a voltage reading on. The input data that the analog pin A0 represents will be a number between 0 and 1023. And we'll see what that means in a minute. Copy the code, so you just copy this, okay? All right, move forward. Send temperature values to the computer. So the function serial print, which we have here, it says send the 10-bit sensor value out the serial port. All right, the function serial print sends information from the Arduino to a connected computer. You will see this information in your serial monitor, which is down here, which we will open in a little bit. If you give serial print an argument in quotation marks, which we did, it says sensor value. You'll see how that works in a minute. It will print out the text you typed. If you give it a variable as an argument, it will print out the value of that variable. So what we're saying is say some sort of sensor value, literally say sensor value with a space and then the actual sensor value. Let's see if that works. I'm going to hit run. You can start seeing what happens. So let's ignore anything that's happening up here. Right here we're seeing, so ignore those lights, okay? So what we just said was print sensor value. I wonder if I can, okay, great. It says print sensor value. That's where this monitor is getting that. It says print sensor value, space, and then the sensor value. So then this is the value that it's getting from this sensor. Okay, it's getting 153 volts, 0.75, and it converts it. Actually, we have those later. So it's just getting a value of 153. And in a minute, we're going to convert that and print even more information. So if I got rid of, let me do that for you. And I will end that bracket so we can run it. Now I'm going to start the simulation and I'm going to open the serial monitor. And you'll see right now, all we're getting, and it looks awful, but we will clean it up. I'm going to stop it so we can see. It is printing, and I can't go to the beginning, but see it says print sensor value with the colon and a space. So it's saying sensor value colon and a space. That's where it's getting that. And then a sensor value. So it's getting a value of 153 from our temperature sensor. Now, if I wanted to clean this up a little bit, I could add a space here. And actually, I would prefer this being capitalized to look even nicer. Maybe add a space. Now, if I run it, you'll see. Start simulation. There we go. So it's a little cleaner now, but it's a little confusing. We'll clean it up in just a minute. Okay, so we have that. It has sensor value, and all it's doing is printing the analog voltage that it's getting. Now that's just some value. Remember, up to that 1,000 mark. 1,000. I forgot the total value, but 153. That's the raw number that it's getting from the temperature sensor. Now we're going to make sense out of that with the next part of the code. So let me get in there. We will click next. With a little math, it's possible to figure out what the real voltage on the pin is. The voltage will be a value between 0 and 5 volts. It will have a fractional part. For example, it will be 2.5 volts, so you'll need to store it inside a float variable. We will get to that. Let's look at our code. So now we had the serial print sensor value, and it was saying 153. Now they want to convert that reading to voltage. So remember, we were getting 153 out of 1024. That was the total number that it could get. So what they're doing is they're saying take whatever number that is. So if we for instance look at my calculator, and we're getting 153 divided by 1024. Then what it's saying is we are getting 15% of the voltage that we could be getting, which is 5 volts total. So we're actually getting 0.74 volts from that temperature sensor. So then what we're doing is we're saying, okay, we already had sensor value. Now we would like you to say comma after the sensor value, right? I'll say sensor value space, maybe 153, and then add a comma, volts, and then we want to say the voltage. The voltage is equal to whatever we're getting out of 1024 times the 5 volts. So now if I hit it, and let me get that for you. Now if I run that, you'll start seeing that we are getting let me stop it so we can read. We are getting sensor value 153, volts 0.75. And if you recall on my calculator, that was exactly what we were getting. It rounded up, not a huge deal in this particular situation. Awesome. So hopefully that's making sense. Let me get back to what we had. All right. Now moving forward. It says when doing mathematical operations in the Arduino IDE, use the asterisk for multiplication and that for division. And order of operations matters. If you examine the sensors, if you need order of operations, maybe check Khan Academy out for that. All right, if you examine the sensor's data sheet, there's information about the range of the output voltage. Data sheets are like manuals for electronic components. They're written by engineers for other engineers. All right, so the data sheet for this sensor explains that every 10 millivolts of change from the sensor is equivalent to a temperature change of 1 degree Celsius. It also says that the sensor can read temperatures below 0 degrees. Because of this, you'll need to create an offset for values below freezing. You take the voltage, subtract 0.5, and multiply by 100. You get the accurate temperature in degrees Celsius. So that's just, it is what it is. It's giving you the formula how to do this. Store this new information in a float. So if we look, here's everything we've done. Converts the voltage to temperature in degrees Celsius. They just told us how that works. So we are taking, we already had the voltage showing. Then they're saying do comma degrees Celsius with a space. Create this thing called temperature that's equal to the voltage. They're just taking this information, okay? Subtracting 0.5 times 100. That's just given to them in the information. We're not making that up. It just comes in the information with the sensor. So they're doing that and then print the temperature. All right, so then if I run that, you'll notice now it is showing, and I'm going to stop it so we can see. Now it's saying the sensor value, which is 153. Then it's changing it to volts by doing that conversion that we talked about right here. All right. And then it's taking that voltage and converting it into degrees Celsius. Now, obviously, if you wanted to convert it into degrees Fahrenheit, you could just add a very basic mathematical formula, a mathematical conversion from Celsius to Fahrenheit, and then you could have degrees Fahrenheit as well. All right, let's move forward. Turn off LEDs for a low temperature. So if we look here, now what we're doing is, it says if the current temperature is lower than the baseline, turn off all LEDs. So if the temperature is less than baseline temperature plus 2, so let's look at this. So if we go up, we have a baseline temperature of 20 degrees Celsius, right? This was saying we're currently at 24 degrees Celsius. So it's saying if the current temperature, right? If the current temperature, this number, if the temperature is less than baseline temp plus 2, then have 2, 3, 4 all low. So they should not be on. Else, if the temperature is more than or equal to a baseline plus 2, and the temperature is less than the baseline temperature plus 4, then turn on pin 2. So this will light up. Then it's saying if it rises 4 to 6 degrees, same thing, but turn on those 2 high. And then if it raises more than 6 degrees, have those 3 high. So walk through those in your mind. I don't want to spend too much time on that. Hopefully that makes sense. So if we run this, we start it, we have 2 lit up. Now I'm guessing I can change it. Yep. So if I make it warmer, you'll see as it gets warmer, that one lights up. And as it gets lower, now you'll notice it does have a refresh rate on it. So if you change that temperature too quickly, you're not going to see the changes. Those of you doing this in real life, holding on to it with your finger makes a huge difference. But as we change those temperatures, you'll start seeing 1, 2, or 3 be lit up. You can have all of them lit up if it's really warm. None of them lit up if it's really cold. That would be below the baseline temperature. We'll click next. Want one LED to turn on if the temperature is at a low value between 22 and 24. The and operate. Okay, so it just walks through everything we just did. Feel free to walk through that. I think they actually seem to be doing a good job on this one, walking you through it if that didn't make sense what I was saying for you. Otherwise, we can use it. So you play around. If you are doing this in real life, what you're going to then do is you've written your code. Hopefully it's very similar to mine. You can obviously change it. You can change it if you're working on it here as well. If you are doing this in real life, what you're going to do is you are going to have your code in here, and then you are going to verify the code. That'll just make sure that it's written correctly. Obviously, if you just took it from the examples, it'll be written correctly. You're going to connect your Arduino via USB, and then you are going to click this one to upload it. Now, you may have to actually set up. This is your serial monitor, by the way, so you can actually see the serial monitor while it's running. It didn't show up because I'm not running it right now. You will have to choose your correct board that you're using. All right. And then you might have to, yeah, that looks like it. And so then you upload it. All right. Otherwise, it looks like we are pretty much done. You're more than welcome to play around with the temperatures, the numbers, seeing how you can affect it. And we click done. Lesson complete, and we're all done. All right, so now that we've completed level meter, keep your eyes out. I will create a color mixing lamp lesson in the future. Have a great day, everybody. Thanks for checking out STEM with Mr. Duda. Please like this video and subscribe. You can also set the bell to notify you when I make new videos. That really motivates me to continue posting these things online and gets you content that you're interested in. A lot of the times I will link a playlist. Maybe one just showed up here. I might also link a video. It might show up right about here. And sometimes YouTube decides what video is best for you, but sometimes I assign one. So thank you so much for checking me out, and have a great day, everybody.